and mathematics. So now coming to Ubuntu for ROS. Introduction to Ubuntu and basic commands. So what is Ubuntu? A freely available Linux-based operating system, open source alternative to Windows. Ubuntu is derived from the African word meaning humanity to others. The most recent version is 20.04, which is focal foci. So these are the very basic commands which you would need for ROS. Uh, so the first one is ls. It stands for list, provides a list of files and folders in a directory. Uh, in the terminal, if you type list ls, you will get all the files and folders in your current path. Got it? So next, cd. Cd stands for change directory. It switches from one folder to another. So now if you type cd followed by the folder name you want to open or visit, you can shift to your desired location. Just to clarify, directory is your equivalent to folder. Okay. Then pwd. Pwd is current path directory. So this is fairly straightforward that if you type pwd, it will give you your current location where you are actually. And next one is mkdir. Mkdir stands for make directory. If, for example, you are inside a folder and you want to create another folder, type mkdir followed by the desired folder name. Okay. Now chmod. Chmod stands for change mode, helps you change the permissions of the file. So typically there are three modes present. First one is read mode, write, and executable. We can change these modes using the chmod command. Right. Now coming to sudo. Sudo is basically runs a command in administrative mode. Basically, this command followed by the other commands, like we'll come to that. Basically, it lets you operate in admin mode and it gives you kinds of superpowers. Like you can run root files without being questioned, right? So like this is just the very basic commands and you can get by in Ubuntu using these. But also there is the GUI which helps you if you are like fairly new. Got okay. So now we'll come to the main point, that is ROS basics. What are the basic commands in ROS and the ROS computational graph, etc. So what is ROS? Open source and easy to use framework for writing robot software, has wide range of tools and libraries to solve complex problems, provides simulation and visualization tools. Why ROS? Provides a standard for robot software development, helps user implement logic and algorithm in simulation without hardware, and supports major programming languages like Python and C++. Right? So coming to computational graph, uh, the ROS computational graph is a peer-to-peer network for ROS processes that are processing data together. The basic computational graph concepts of ROS are nodes, parameters, server, master, messages, services, topics, bags. All provide data to the graph in different ways. So as you can see on the right side, this is, you can see the components. So let us discuss some of them in detail, right? So first one is the ROS master. The ROS master provides the naming and registration services to other nodes. It tracks the publisher and subscriber of nodes and connects them. Basically, the ROS master is like a DNS server. DNS stands for domain name system server, which assigns unique names and process IDs to all the other elements. So when we start any node, it starts to search for the node starts to search for the ROS master, and it gets itself registered with a unique name and a process ID, right? These node related details are useful for connecting with other nodes. Like this is the internal working what I just explained. uh, so next, node executable slash scripts under which topics and services communicate. Each node has a unique name. Multiple topics and services can be written in one node. So node is like a executable, that is your program file is called a node. So this is pretty straightforward, right? Next, ROS topics, software buses to transmit data. A published topic can have multiple subscribers, but message type and the topic name should be the same. So ROS nodes basically exchange ROS messages via topics, and communication using the topics are unidirectional. Okay. Now coming to the next one, ROS messages. Nodes communicate with each other by passing a message. A message is in the form of a data structure comprising typical typed fields. For example, sensor underscore messages slash image. So this is also straightforward that a message has a typical data structure, and in that message we store what we need to transfer via topics, and that we write inside a node. Okay. So coming to the next part, services. So services is like another part of the computational graph. The publish subscribe model, as we saw earlier, is a very flexible communication paradigm, but it is many to many and one-way transport, and is not appropriate for request reply interactions, which are often required in a distributed system, right? So I think we understood what this says, but I'll give you an example. So there are two nodes, and one node acts as a server, and the other is the client. And client requests the server uh, for a service, right? And I'll give you an example after this. Coming to bags, ROS bags are a format for saving and playing back ROS message data. Bags are an important mechanism for storing data, such as sensor data, that can be difficult to collect, but it is necessary for developing and testing algorithms. So this is ROS bags are used for data logging, and once you use ROS bags and you have logged your data, then no need to run the node again. Like if you just play, there's a command called ROS bag play, and if you do that without anything, like you can rerun your entire simulation. So this is the this is a pretty helpful and important, right? So just to sum up all the uh, components of a computational graph, let me give you a real life example. Okay. So for example, you have your own mobile robot, autonomous mobile robot. It has a laser scanner, that is the sensor for obstacle detection, a face recognition system, and a navigation system. So the laser will use a ROS topic to publish all the laser readings, and topics because we need info all the time for the ROS system. That is, we need only one way communication that constantly keeps us updating that, okay, now the obstacle is at 10 meters, 5 meters, 4 meters, like that, okay, for navigation purposes. Second, here now I will explain that why ROS services is important. So face recognition system, if we use, we will set it up in such a manner that if else condition format, okay, like if you recognize this face, then you move ahead or else not. So face recognition system will provide a service. The ROS program will call a service and wait until it gives you the name of the person. So that is, as I mentioned, that a server will be there and a client will be there. The client is the one who is asking for the service, and it will wait for the server uh, to recognize the person of the to recognize the face of the person and respond, right? And then later on, that action will be given to the navigation system, and according to that, it will do its path planning and everything, and it will move forward, right? So far so good, clear? Okay, next. So now these are the list of ROS commands what we'll see. uh, I'll show them doing practically, but for now, just let's just understand everything, right? So first, raw score. This is the most important and the basic command which we need to run every time, as it says that it starts the ROS master, and without the ROS master, we saw earlier that inter-node communication won't be possible. So first one is the raw score, and it is the most important. Okay, now moving on. ROS node. So these are the commands related to ROS node. First one is ROS node list. Lists all the active nodes in the network. Okay. So, for example, if you're running a program and you need to see what are the list of active nodes uh, in the program running. So you just type ROS node list and you'll get all the list of the commands. List of the nodes accordingly. Okay. Now, if you want further info on a particular node, just type ROS node info followed by the node name. It gives you details about node, the publisher, subscriber, and the topics which are associated with the node. Right now, if you want to stop a node from publishing further data, you can simply type ROS node kill node name followed by the node name. Straightforward, right? Uh, Now the next one, ROS node ping node name. It checks the connectivity of the node, that either is it working, is it publishing or not, like that. Okay. So ROS CD. It like CD when we saw earlier, this usually is used to change directory from one package to another. So we'll come to what are packages, but here you need to understand that when we do CD followed by the name of the folder, we change the directory. So like that, ROS CD when we do change from one package to another. Okay. Next. Uh, so ROS topic. Now, previously we saw the commands related to ROS node. Now we'll see related to ROS topic. First, ROS topic list. It gives the list of all active topics. So there is a difference between topic and node. Node is a script and topics are the what we say pipeline basically for communication between two nodes, right? So you'll get the list of ROS topics using ROS topic list. Then from the list, after you type ROS topic list, you'll get one particular name, for example. Then you'll do ROS topic info, topic name followed by the topic name. It provides the detail of the topic. Then ROS topic echo topic name, it publishes the data onto a given topic, right? So there are two ways of working with nodes. One is you can include the topic name in your script, and then when the script is executed, it will the program starts running basically, and the process is completed as desired. Or for testing purposes, you can use ROS topic echo followed by the topic name. There you in the command line terminal, you can simply give some random values for testing, and then you can check if the uh, bot in simulation is moving or not, right? uh, so that was for ROS topic pub. ROS topic echo is like for printing the values, and for publishing it is ROS topic pub, topic name, and the data, that is what you give. I'm sorry if I caused some communication misinterpretation, but ROS topic echo topic name only prints the data that is being published. ROS topic pub gives publishes the data onto the topic. Okay. And next command is ROS run. So this command is used to run the executable node what we have written. The command goes like ROS run package name, the package inside which the file is present, followed by the node name that will run the ROS run node that will run the node. Coming to ROS launch. ROS launch runs the launch file. So just in brief, a launch file is used when there are multiple nodes, and instead of typing ROS run multiple times, that is, if for example you want to run 5 nodes together, instead of doing ROS run 5 times, you can include all those files inside a launch file, and then you can execute all at once. And ROS launch, the command, it takes care of the ROS core as well. That is, it launches the ROS master also automatically if it is saved as a launch file. Okay. So coming to ROS package, as we saw earlier, what was the package and what is the Catkin workspace? Okay. ROS package contains all the files related to the robot. So these are the basic files that are files and folders which are present inside a package. CMake list txt, that is a file that contains executable dependencies and the libraries required to build the package. Package.xml, this is also a file that contains the authorship and maintainer info along with build and run dependency. src folder, src is the source folder and it contains the source C++ source codes, that is the C++ scripts. Include folder contains all the header files and their definition. So for example, sometimes when we need to create our own classes and everything, we define header files for the C++ thing I'm saying. So that time the header files which are defined, that are saved in the include folder, and the main code is present in the src. And scripts folder, this is also a folder that has the python scripts. Python nodes are cmake independent, hence they do not require any prior build or run. Matlab, they do not need to be compiled basically before building, right? So this was about the Catkin workspace majorly, and the ROS package is all contains all the files related to the robot. Uh, Now coming to Catkin, creating a Catkin workspace and a robot package. Make catkin underscore workspace folder in home. So how to make a folder? As we saw earlier, mkdir catkin underscore workspace. Uh, if we type this, it will create a folder for us. Change directory into catkin workspace. That is cd tilde / catkin workspace. So tilde here indicates the home directory. That is like the shortcut for typing home. Okay. How to make a package now? Make a package with the name src mkdir -p src. So this creates a package called src. Now, if we do cd src, it will go inside inside the src folder and initializing a catkin workspace. So we need to initialize a catkin workspace so as to differentiate between a ROS package and a workspace, right? Uh, so this is done by typing the command catkin init workspace. And after that, we need to source this workspace in the .bashrc file. So .bashrc file is kind of like the root level file, and this file gets executed every time we open a terminal. So what happens is, now if you want to open a terminal, uh, our package should be defined, right? The ROS package should be defined in Ubuntu, saying that this is a ROS package. And when we open a terminal, it should be able to differentiate within a package, a folder, and a workspace. So that is why we need to source this catkin workspace inside the bash rc. Now changing directory into catkin workspace, and we have to make the catkin workspace. That is, we initialized the catkin workspace using catkin init workspace, and then we are compiling it using catkin underscore make command, right? So now in the src folder, to create a package, to create a ROS package, we can create our own arbitrary packages, or we can download them. Like, there are pre-made packages in ROS. We can use that also, and we can build on it. Like, we can write our scripts and fine tune the package according to our needs. So in case if you want to build a package from scratch and you want to make an entire project, so for this, inside the src folder, that is inside catkin, and inside that the src, we go and we type catkin create package, catkin underscore create underscore package, space the package name, that is what package you want, what is the name of the package that you want, and followed by ROS by ROS CPP and standard underscore messages. So these three things, ROS by ROS CPP and standard underscore messages, are the client. ROS Py and ROS CPP are the client libraries, and standard underscore messages are the list of standard messages, that is int 32 string and all that. So basically these three things are called the dependencies. So while creating a package, we need catkin underscore create underscore package, package name, and followed by the dependency which you want. So these dependencies are used when these dependencies are important as when you're writing your script. So the script will depend upon these. So right, suppose if I am importing ROS by here, that is by adding the dependency here, it means that I can now import ROS by in my script. So we'll see that now. One second. So now is the time to implement. I'll just show you how everything is working, right? So give me a second. Hello, is the Ubuntu screen visible? Hello?
Yes.
Okay, cool. Right, so just a second. Let me just log in. Okay, so now this is your home screen in Ubuntu. I hope it is visible in full screen. Just a second. Right. Okay. So yeah. So as I was saying, this is the terminal. This is another app called Terminator. Like this helps you split a screen in 4 ways or multiple ways. So it is similar to the terminal just for now. Okay. So this is the home directory. As you can see here, one second. Let me just zoom in for this. Right. Okay. So here, this sign which I'm highlighting in blue, this one shows that we are in the home directory. Okay. Now, if I type the first command, what we saw, that was ls, right? So by ls, if I do, I'll get a list of all the uh, parameters that are present in the home directory. So here I can see the Catkin workspace. This is the workspace which I had already made. So if you guys want to try out, you can just download virtual machine and you can try it out by yourself. It is perfectly safe to use a virtual machine as you guys are beginners. So yeah, so this is a Catkin. As you can see, there are Catkin workspace, desktop, documents, etc. Okay, so now if I want to go inside the Catkin workspace, right? So I'll do cd space Catkin underscore workspace, enter. So now we are inside the Catkin workspace. And as I had shown, what we had done, that inside Catkin workspace, we had created a folder called src, right? So src is there. This is the one we created. But after doing catkin init workspace, there are two other folders, build and devel, that are created by the system itself to define this as a workspace. Okay. So now further going into src, cd src. Okay. Now we are inside src, again ls. So here you can see these are like the test packages, whatever I have made. Hello world, ROS underscore workshop, etc. etc. Okay. So now going into cd ROS underscore workshop. Okay. Now again ls. So uh, here inside a package, as we had seen earlier, the src folder is present for C++ files, scripts folder for Python files, package.xml for dependencies and authorization, and CMake text for the system descriptions. Okay, and include file is there for adding the header files. Okay, so also I would like to give you guys a trick, or you can call it whatever you want. So let me just go to home again. So cd this tilde. Okay, so I'm back in home folder again, ls catkin workspace desktop documents. Okay, so now if you want to clear this, right, you have seen all your commands here, right? So you can type, you can press Control plus L. This clears your screen. Or And also, so instead of typing out the command every time, and if suppose you have used it previously, you can just uh, tap on the up arrow to go to your command. So for example, I had just typed ls last, then after that cd tilde, then like that. Okay, so you can do this. So now I had mentioned the ROS CD thing. Why is it important? So for example, ROS CD, and we know that the package name was ROS underscore workspace, right? So ROS underscore workspace, sorry, workshop, right? So if I do enter, it goes in. Clear. Uh, Now one more tip I would like to give. Let's just go again inside home folder. Okay. So now let me just clear. I can either type clear or control plus L. Okay. So now, since I'm in the home folder, let me just show you the .bash rc file, right? Gedit. Gedit is a tool to open the notepad equivalent of Windows. Okay, so gedit.bash rc. Wait. Okay, so this is the folder file. Sorry, right. So this file, we haven't written all these things. This was a system file, as I had said. So here in the end, this line, if we add, this is called sourcing your Catkin workspace. So this is source, home. This is basically the location of the Catkin workspace. That is, Catkin workspace is inside home, right? So source tilde is home forward slash Catkin workspace devel, and this. So this sources your Catkin workspace, and all the packages inside uh, the Catkin workspace are then defined as a package. Okay, so that's why we could directly just do ROS CD followed by ROS underscore work. See, now if I'm just typing WORK and I'm hitting tab, okay, so it auto completes. So again, one more tip is that if you know your package name and if you know its location, you can just simply type the halfway through and hit tab and you'll get it, right? So now let us see some example program. Okay, so let me just split this screen first, or wait, I'll just first go to the scripts section, right? So ls cd scripts. Okay, ls. So now here we can see three programs, right? So you might wonder that what is the difference between the green ones which are highlighted and the one that is not. So the thing is, these two programs are executable made by me. Okay, so that is, I have written the program, and after that I have used the command chmod to change its mode, that is to make it executable basically. Okay, so I'll just do once again. Okay, so here it is clear. Okay, so now let us see what this program does first, right? I'll just execute for you guys and show. So first, as I had said, we need to start the ROS master by typing ROS code. Okay, so it is taking some time. Right. Okay, so now this, here it says that ROS master URI, that is the ROS master has now started, right? So now here, just a second, I'll just zoom in for you guys to see what I'm typing. Okay, so I'll type here first. So what was the command to execute a file? It was ROS run followed by the package name. Package name here is ROS underscore workshop followed by listen. First, let's say, okay, talker. So there were two program files, as you saw. One was talker and one was listener. So I'll just type TALK tab. Okay, talker.py. So this has now come here and let me just type here first before I have not executed that file. Just a second. Again, ROS underscore workshop followed by listener.py. Okay. So now coming back here and I'll just execute this file. Okay. So here what is saying is hello world. Okay. And now here what it is saying, let us see. Right. Here it is saying, I heard hello world, right? Here, I heard hello world. Okay. So, okay. One more thing, there is another good visualization tool called RQT graph. RQT stands for ROS QT graph. So what it does is it wait, I'll just show you guys. Okay, so RQT graph is also a package. So what would be the command to run it? ROS run RQT underscore graph followed by RQT graph. So the executable name is also RQT graph here and the package name is also the same. Okay, so let us just execute this and see what is happening. Okay, so the thing is a bit slow. Sorry for that. Okay, so now this is the RQT graph. So this helps in 2D visualization, basically how things are working. Okay, let me just zoom in for you guys. I hope it is visible. I don't know how to zoom here. Hello, Nihal.
Yeah.
Is it visible? Wait, I'll just do this. Like, if you guys cannot understand what is written, so I'll tell you guys. So this part on the left side is the talker node, like the one which we executed first, and here is the chatter and this is the listener. Okay, so what is happening basically is that the talker is a node. This circular thing or whatever you call it is the publisher node, and that is publishing on the chatter topic, and this listener is the subscriber to the chatter topic and it is listening to it. Okay, so just what we say, just keep this in mind for now and I'll show you the code how things are working. Okay, I'll just stop here first. Okay, and you can just press Ctrl C to close the terminal. So to close the program, that is to stop it midway. Okay, now Control L, just okay. So now coming to the program. Okay, just a second. So this program what I just showed you guys is the hello world of ROS. You can say that. Okay, just a second. Sorry, the PC is too slow. One second. Okay, so this is just the VS Code thing. It's not important. So I'll just open the talker node first, as we saw that. I hope you guys can see the screen, the code. Is it visible clearly now? Hello? Nihal?
Yeah, it's visible.
Okay, cool. Thanks. So I'll just walk you guys through step by step to this through this basic code of Talker. Talker is the publisher and listener is the subscriber. Okay, so let me just show you guys the important things. So the first line here itself, this is very important. This is known as the shebang line. So what this does is the shebang line does that we are basically using Linux, right, for working. So if you guys know that C++ is Linux compatible, that is you don't need to do the extra stuff for doing this. So basically this first line, the shebang line does is that it tells the command line terminal that, hey, this is a Python script and we are executing a Python file. So this says that env stands for environment, and the Python, and this is a Python environment, and this code or node or script is Python script. Okay, so the next line coming to import ROS-Py. Okay, so ROS-Py is the client library. So as we saw that what are the advantages of using ROS, that the client libraries are very vast in ROS, and all the features are very easy to use. That's why we use ROS with Python, or you say C++ or whatever. Okay, so import ROS-Py does is imports ROS-Py, quite standard. Okay, so now from standard underscore messages dot message import string. So what we're doing is standard underscore messages dot message is a package. Okay, from that we are importing string. So as I said that standard underscore messages was a dependency what we had added. So okay, so before that let me just do one more thing. I'll just run this again to show you guys what I'm talking about. Okay, so here I'm running and I'll just zoom. Wait, I'll just minimize this. Okay, so for now this is not important, like it's just running in the background, so I'm focusing on this part. Okay, so here now what are the top commands what we had seen regarding ROS. So first one was ROS node list. Okay, so what it does is it gives you the list of the ROS nodes which are running. So these are the two nodes. These nodes we saw in the RQT graph as well. So basically this is just the terminal version of that. Okay, so ROS node list was first, and then ROS node info followed by the node name. So here we'll just, one second, we'll just copy this thing, control, okay, whatever. Okay, so what this does is it gives us the information about the talker node, that is publications are chatter. This is the chatter, that is the topic on which it is publishing, right? And subscriptions are none. Okay, because this node doesn't have any subscribers. This has only a publisher node, right? As we established it quite this. Okay, so coming here, okay, topics chatter. So topic is a chatter, and topic is chatter, name of the topic is chatter, and it is publishing to the listener node, right? Topics, okay, these are not important as of now. So I hope these two commands were clear. The other ones are also quite what we say, straightforward. I'll share you the PPT with you guys later if you want to go ahead, or I'll just give you the link of the documentation. Cool. Okay, so now coming to ROS topic. So what was the first command? ROS topic list. So this gives the list of topics, right? So we have only one topic. So these two topics are not of importance to us, as this is published by the ROS master, you can say. Okay, so ROS topic list, one topic we have defined, that is chatter. In the code here, I'll come to it, but for now we know that the topic name is chatter. Okay, so ROS topic list was the first. Now if you want to know more about the topic, so what is it? ROS topic info slash chatter. Okay, so this gives information about the type, that is the type of message being published. So this is a string command, right? String message, I mean hello world. So it is telling us that, hey, standard from standard underscore messages package, it is publishing the string data type, right? And it gives further more info saying that publisher is talker, that is publisher is publishing string message, and the subscriber is listener, right? Okay, so one more, like if you want to go further, like you want to know what is the message, like you want to know the data of the message. So now ROS message show, and now this, right? This copy, paste. Okay, so here this is the data type. Okay, this is string. Okay, string is the data type, and this is the variable that is data. So I'll come to it. Just remember that this was the thing which was present in the string file. Okay, so now let us go back to the code and see what is what. Okay, so till here it is clear. Like, this was a shebang line, declares that there's a Python environment. We're importing the ROSPy client library, and from standard underscore messages dot message, we're importing string. Okay, now we're defining a function called define talker. That is, okay, now here we can name it differently, but I've just named everything similar for the sake of ease. Okay, so now the first line. Okay, here also these three lines you can write it like, the order is not important. So firstly I'll tell the second line what it is. So this line says that rospy.init node talker anonymous equals true, right? So what it does is that the we are initializing the node basically with this line, that rospy.init node, and the name of the node is talker. Talker is the name of the node. Talker is the name of the node, and anonymous equals true. So this is also important. What this does is it ensures that every node is unique. For example, you can write 10 nodes with the name talker itself, but it should be true, as we saw here. One second here. So there was some ID, right? ROS node list. If we do again, we saw that here this is a unique ID which is provided. Okay, sorry, here, since this is talker, this is a unique ID. So this is done with the help of anonymous equals true. Okay, and now the second line, that is pub equals rospy.publisher chatter string and queue size. Okay, so uh, pub is a variable. Okay, rather pub is an object. Okay, pub is an object from that we are instance, we are creating an instance basically. uh, this is an OOP concept. You can just remember it like this, that we're creating something known as pub, and we are assigning it rospy.publisher. Here chatter is the name of the topic, followed by string, that is the type of the topic, the data type, and queue size. So what queue size does is, okay, let me just, okay. So what queue size does is, queue size is a buffer. Here we say that queue size equals 10. So it stores up to 10 values before deleting in case of a backlog. That is, if there is a delay between the publisher and the subscriber, you can store up to 10 messages, so that there is no loss of data, right? Uh, so moving on, now rate, rospy.rate is 10 hertz, basically 10 messages per second, if I'm not wrong. Yeah. So rospy.rate, here you're writing the rate here, 10 hertz. Okay, straightforward, right? So now while not rospy dot is shut down, basically we are running a while loop saying that till the time we don't press Control C, that is, we are not shutting down the program. What you have to do is hello underscore string is a variable which will which will have the value hello world, followed by percentage s. This is publishing the time, that is, it is adding the variable thing. Okay, now rospy.log info hello underscore string. So what log info is, it is basically print. Okay, like in rospy or ROS, print equivalent is log info. Okay, now we are printing publisher. Okay, I mean, we are just publishing the log info, but we need to publish this onto the topic named chatter, right? Hence we write pub dot publish hello string. So pub is a publisher, as we initialized here, that rospy, okay, sorry, rospy dot publisher, and then we are publishing it by using dot publish hello string, and then rate dot sleep, so that it is what we say, time elapsed since the last successful sleep, right? So now this is this was the meat of the program. Now we are just executing this. That is, if name equals main, try talker. That is, we're calling the function talker, what we just described, and except rospy dot interrupt execution pass. So this is like try and except thing of Python. Okay, so if we just try to stop, then stop, otherwise keep running. Okay, so this was the talker node. Now coming to the listener part, right? I hope you guys are understanding. Okay, this is just the very basics. You can ask me later if you have any doubts. Okay, so now coming to the listener part, that is the subscriber. So again, here the same thing we are doing. These three part will be same. That is, we are importing rospy, and from standard messages package, we're importing string. Okay, but one additional thing here is that we have to define a callback function, a callback with the parameters data. So if you guys remember, I told you to remember here that ROS, wait 1 second, I'll just ROS message show this. So here data, right? That is the data what we write here. Okay, so that it has the parameter. So rospy.log info again, and caller ID is like the thing which is getting published here. Okay, like 1 second. This is the caller ID. Okay, so rospy.log info, I heard hello data. So you can just write here message also, and message.data. So what happens is that I heard hello world. So the data is getting published from here. Okay, right? This is the hello world thing, and that acts as an input for this callback, and then I heard data. Okay, so now again we are just initializing the node called listener, and anonymous equals true, so that there can be 10 listeners, 100 listeners, whatever, and then rospy.subscriber, declaring this node as a subscriber node, saying, okay, so here if you see, publisher had also three parameters: the topic name, the data type, and the queue size. So here in subscriber, the topic name and the string, that is the data type, are always there. So callback function. Okay, so what this does is this is automatically executed as soon as a new message is received by a subscriber. So here tens of messages are constantly being published, right? So every time when a new message is published, it goes to the callback function, and as soon as the callback function gets a new message, it is being published. So that's why if you see, 1 second, here it is constantly saying I heard hello world, right? So that is because of this thing. Okay, and rospy.spin, what it does is that this starts the listener node to listen, that is the subscriber node, I mean, to listen infinitely. That is, it keeps on listening for a new message, right? And then if name equals main, listener. Okay, so I guess this was quite satisfactory explanation for the first hello world program. Let's just go through it again quickly. So first line is the shebang line. Second, that is, it indicates this is a Python environment. Second is we are importing the rospy client library. Third is from standard messages package, we are importing string. Then def talker, that is, we are defining the talker node, talker function here. But here rospy.init node is, we are defining this node as a talker node. Then we are creating a publisher with this line. Then we are defining the rate, and then we are using a while loop that till it is shut down, keep publishing hello world. Okay, then here as I explained, that callback function, what it does is it automatically execute every time. That is, the function is being called back again and again, hence callback, that as soon as a new message is received. Okay, clear? Right. So now this was just a introductory program, right? Uh, I'll just close again and start. Okay, now coming to the turtle sim part. So what the turtle sim is like a 2D robot simulator, which helps in learning concepts for ROS, you can say. Okay, so again, if you want, okay, for example, there is ROS. So the turtle sim package is installed as soon as you install the ROS packages and everything. Like you do the complete ROS installation, that time the turtle sim package is automatically installed, right? So for example, if I just forget to run the ROS master, and if I try ROS run turtle sim underscore node, so what it will give, it will give me an error saying failed to contact master. So this is trying to say that, okay, hey, the master is not present, I'm just trying to recontact. Okay, so and the most important thing is that once a communication between ROS, so a publisher and a subscriber is established, you can shut down the master. So it then does the communication at a local level. So we can see that also. Just a second, I'll just start with uh, turtle sim first. So I started ROS core. I'll just close it because we don't need it. Okay, so ROS run. Okay, so what I did, okay, so now this is the turtle sim 2D simulator. Okay, so I'll just mark it always on top, right, so that it doesn't minimize every time. Okay, so now there is another script which helps us control this bot using keyboards. Okay, so that is ROS again inside the turtle sim package. So if I do turtle and I do tab, right, so it got, and now turtle under. Okay, now if I don't know the name, exact name, if I hit tab twice, so it will give me that, okay, hey, there are two nodes inside turtle sim package, that is turtle sim node and turtle teleop key. So the teleop key is a keyboard control for uh, the the turtle sim. Okay, so now I've executed it. It says reading from keyboard, use arrow keys. So now if I use the arrow keys, you can see that the turtle is moving, right? So again, if you want to see at the background what is happening, okay, so here we can do is, I'll just do the ROS node list and everything again. Okay, let this be here. Now ROS node list. Okay, so what it does is, we executed two nodes, right? First was turtle sim node and the teleop key. Sorry, the teleop key. So here it shows, right? These are the two active nodes. Now again, ROS node info followed by turtle sim. Okay. So again, now this has given us a explanation that uh, these are the services that we can, as I had said, that it was a request and execute method, that it was not a one-way communication thing. So if we use this, right, so let's just try. So for that, again, a new command is called ROS service call. This is, we are calling a service called spawn, for example. Okay, spawn. Okay, so I'll just call it spawn. Okay, wait, spawn, and now if you again press tab, so this is what it gets. Okay, that is, this is the data that we need to provide for the location of that. So if I do spawn, okay, this is turtle 2, and you can see at the bottom here, at the bottom, that another turtle has come. Okay, so now if you, this is this much. Okay, so let's go to the ROS topic list now. ROS topic list. So okay, hey, now this turtle, 1 second, I'll just restart this entire thing. Right, so every time you run the turtle sim, you'll get a different turtle. That is, these turtles, fun fact is that these turtles are different distributions of ROS over time. Right, this one is the noetic, this is the latest version. Okay, so coming back, ROS topic list, if we do, so here you can see that turtle 1 has, this is the turtle 1 bot. It has 3 topics related to it. First one is CMD well, color sensor, and pose. So color sensor just changes the color of this from blue or whatever if you want to change the values. So let us see what is CMD well. Okay, so what was the command for that? ROS topic info followed by topic name, that is turtle1 CMD well. Okay, oh sorry, so yeah, for copying inside the terminal, instead of Control C, you have to do Control plus Shift plus C. Okay, so again, I know the name, so turtle1 slash CMD tab. So it came. Okay, so let us see what is the info. So publisher is a teleop turtle, and subscriber is a turtle sim. So what, and the type, most importantly, that it publishes geometry messages and slash twist. Right, so let's go further into this. Control Shift C, and then ROS message MSG show followed by geometry messages. So what it does is it shows that geometry messages is a vector format with 3 linear values and 3 angular values. Cool, right? So as we had seen another, for just trial and error, what I had said, that was using ROS topic pub command, right? So just to move this in circle, okay, ROS topic pub forward slash topic name, that is turtle1, sorry, turtle1 slash CMD well, right, followed by data, that is the data, like at what speed we need to move it or something, right? First we have to give the message type. Message type here is twist, and the package is geometry underscore messages. Okay, again if we press tab, it auto completes, and now for moving it in a circle, we know that we have to give angular z, say 2, oh shit, sorry, so yeah, angular z. And now here you cannot use the up arrow, as I had said that if we press the up arrow, uh, you will go to the previous command what you had typed. Okay, so you have to just use the back left arrow to go up like that. Okay, so as I said, to move it in a circle, we need linear x and angular z. Okay, so I'll give this, and now if I press enter, right, so it is publishing, right? Wait, what happened? Okay, so it published, but for some reason it stopped. Okay, let us just try again. Let's see what happens. Okay, so it is latching. Okay, anyway, so this was just an example to see how we can use the terminal using ROS topic pub followed by the uh, topic name, and then followed by the message type, and then if you press tab, it auto completes with the data. So this data we saw here, that from ROS message show also, this is the same data, right? That linear, it has xyz float values, and angular, it has xyz. So here also linear and angular. Okay, clear? So now let us just go back. I'll just close this terminal again. Okay, I'll close the teleop keyboard also, right? And now what we'll do is we'll go to our package, that was ROS CD ROS underscore workshop tab. Okay, now ls cd scripts. Okay, ls. So here, if I want to execute this file, right, since it is a read only file, it won't be detected by the terminal. So let us just try typing it out. Okay, ROS run, uh, ROS underscore workshop, that is the package name, followed by turtle underscore circle dot py. Right, so it says couldn't find executable name, this found the following, but they are either not files or not executables. So as I said, it is not an executable. So to make it executable, we have to do is chmod, that is change the mode, plus x, that is to plus x stands for make, plus is like the assign thing, that x is executable. So chmod change mode to executable, followed by the file name which you want to make it executable. Okay, so if I do tur tab, so it knows that okay, in this description, in this location, there is only one file that is not executable, so I have to change it. So if I just press tab, it auto completes, enter. Okay, now again ls. So if you see that the color has changed to executable, right? So now clear. Okay, I'll just do one thing. I'll just explain the file quickly first before we start on. So again, here we saw that this is the shebang line which makes the terminal know that this is a Python file. Okay, now importing ROS.py. So there, previously when we saw the message type, it was geometry underscore messages, right? Just okay, wait, I'll have to. Okay, uh, we'll see that again if you want. And then the message type was twist, and this was the package. Okay, now again we have defined move circle, then we have initialized the node saying turtle underscore circle anonymous equals true, pub equals rospy.publisher, and this was the topic name of the turtle, and we need to move the turtle. That's why we are using turtle1 cmd well, followed by twist, and then queue size. Right, now as we see here, twist is a class, right, and we are creating an instance of it that is called an object, right, that is well. Okay, so twist message, if we see, we had linear components with 3 xyz, and again angular xyz. So what we have done is we have created an instance here, and then using the dot operator, we have we have called the linear method, and inside that the x version. So if we give here like linear.x, that is I'm assigning linear velocity as 1.5 and angular velocity as 1, and then I'm publishing well, because well has the twist class, right? So we have to publish that onto the topic named cmd well, right? Now, in this case, you might be wondering what is the subscriber. So, any idea? Okay, if you guessed that the subscriber is turtle sim node, then you are right. Okay, so again, this is the publisher standard thing that you have to write. Try the function what we have defined, move circle, except rospy.interrupt exception pass. Right. So now coming back, I'll just start the turtle sim node again. Okay, so as you can see, another color again, right? So now coming back to running that. Okay, ROS run followed by package name, that is ROS underscore workshop, then followed by the script name, that is turtle underscore circle. So now it auto completes because we have made it executable, right? So now if I press enter, you can see that the circle, the bot has started to move in a circle, and it will constantly keep moving until we just close it, right? So now here, if we do ROS topic list again, right? So we can see, okay, wait. So we saw this earlier, right? So I'll do one thing. I'll just run the RQT graph for this. Okay, RQT underscore graph. Okay, so this is the RQT graph for us. I'll just minimize it for now. So what it is showing us is that we are publishing from turtle underscore circle to the turtle sim. That is, turtle sim is the subscriber, and turtle one cmd well is the command velocity topic on which we are publishing the values, that is linear x and angular z, and the turtle sim is listening to it, and hence it is moving in a circle, right? So I guess this is the end from my side. If you guys have any doubt, you can ask me now. Hello?
Mics have been enabled for everyone. If you want, you can unmute yourself and ask the question, or you can type it out in the chat box.
Are there no questions? Hello?
Are there any questions? Okay, so if there aren't any questions, then I think we can stop here. Do fill up the feedback form for this event so we can help you with any more workshops in the future and take any inputs from this workshop from you guys. And also do follow the Discord server, which I've added in the chat box over there. So if anyone has any wants to learn ROS or get anything like this, and we'll be more than happy to provide support for that, be it helping dual booting Ubuntu or getting started with the basic ROS related commands and everything. So do join our Discord server, and we will be posting the recordings for this workshop and the previous workshop that was held last week on our YouTube channel. So we will be informing on the Discord server once that is done. So once again, do join the Discord server for any further updates or anything. And with that said, I think we can call it a day. Tejas, anything you want to add from your end before we stop?
Yeah, I'd just like to ask for some feedback. Like, how was it? Was it uh, like the data that was put forward for you guys? Was it satisfactory? Do you guys understand well? Like, if you, just tell us anything, what is there in your mind, so that we can improve on it. If not, so yeah, you can just type it out if you don't want to switch on your mic or anything. Hello, how was the session? Like, okay, thank you, Shweta. Course was great for a beginner's understanding. Yeah, sure. That is the aim. Like, if you guys have not joined our channel, you can join. We'll provide you software or support if you want, and then you can just start off exploring ROS. So I think you guys should start off using the turtle sim of how I explained, right? You can draw complicated shapes, like you can draw the shape of a heart or something like that. So yeah, this is it, I guess. Anything else, you guys?
Mm, Okay, then. All right. I guess then we'll stop here for now for you.
Yeah.
So thank you for
Thank you
attending
guys for
and have a
joining.
good day.
Yeah. Thank you guys for joining in. Hope you guys enjoyed this. See you guys soon in the next workshop. Probably it would be related to designing or anything. But yeah, see you guys. Stay safe. Bye bye.